thanks to Marlin for some beers and some wurst last night, and I was really struggling to get good sleep because all the time at night there was too much going on. So I was thinking, oh, what can we do tomorrow? And I was hoping yesterday that I could go ahead further, but each boat already took too long. So for today, change the plan. I cannot do every boat in all details because that will take a week. We grab one boat, which will be 9171, which has a normal layout, so it's easy for me to go through that boat and explain this, and then everybody can ask questions, and we go to his boat and say, look at this system, look at that, look at that. You can see how you do the pull downhole and. Otherwise, the day is too short today. So what we will do on that boat now is start with measurements. So yesterday I just got an overview, what is really wrong, what is matching, where is the mast and an end. We've checked the bottoms, we've checked the centerboard. I was very disappointed how poor conditions the boards were. Some that did not even turn into the boat, some had really bad shape of surface. But the really bad thing yesterday was to see all the boats, nobody was putting any grease into every ball bearing, every block, every this and that and that. With your car, you don't just go to a petrol station, put petrol in, you buy new tires, which is new sales compared to a boat. But you go to a service, and every 2 years, if you don't get it checked, and don't get the new stamp on the number plate, you're not allowed to drive your car. So you must service better. Every month or after every 5 times sailing, take a little can with some lubricant and go to every ball bearing, every block, into every bearing. Every bearing needs grease. Your car gets service if the machine you use at home to cut the grass in the garden gets oil. Every machine on the farm gets grease and oil and gets serviced and an end. So like when I was a kid and I grew up on the farm, all the machines of my father, every bearing had a little spot where you put a pump on and you put some grease into the bearing. That's what every boat needs all the time also. Yeah. And more than your car. Because you have salt water. And dirt. That's for example why for me it's a personal no-go to sail a major regatta from a beach. No way for me. Because one piece of sand in the centerboard case will fuck up the whole centerboard. You turn it and you scratch it. The sand goes into all bearings and an end. So it's impossible sailing from a beach to keep the sand away from your boat. Because it will be in everywhere.
That's true.
So a lot more boat care. And an older boat needs even more boat care than a new boat.
Quite natural.
Yeah. So what we will do on that boat, we just pick one sample to show. First, you need to know how you sail. You need to have indicators showing mast rate, jib in and out, and you need to remember how do I sail, where do I use it for next time and compare. Especially here because all the boats are different. When we were training at home a lot, all teams with similar boats, we could even sail upwind and communicate with fingers. I could show to the shrouds and show to our training partner, shroud 5, and he was answering 4, or show on the mast ramp at the position here 3. So we had the same numbers on every boat. So communication while going, not stopping, would even work without a walkie-talkie. What you can get, well, if you do speed training, 3 boats, 4 is too many, 1 will always drop back, and with 2 you don't see the shift so much. With 3 is ideal. If you can get a walkie-talkie here in the buoyancy, you can communicate with the others while you're sailing. The skipper can just push a button and say, hey, I put more bang on now. One boat is adjusting something, not the others not. Only one, and then you go another 2-3 miles to see a result. If everybody is adjusting something, you don't get anywhere, because you don't see the result, because you don't know what is causing what. So always just one boat adjusting one thing. So Martin showed me some pictures yesterday from training, which looked okay, and you did better than the others, but that was not even 90% of perfect running. It was still too much heel and not enough mast rate, overpowered, and. So try to get somebody out with a coach boat who's taking pictures, even better, does some filming. Even better, find somebody who can fly a drone and land it in his hand on a coach boat. So he can land it, and when the drone is following you to film, not too high, because from above you cannot see so much. Better is from behind. From above is okay to film maneuvers, because you can exactly see how you move in the boat if you film from above, but you cannot see sail or how you drive from above, because when you film from above it always looks like upright, because you cannot see this or that. So you have to try different angles, but it's good for if you want to look at boat handling. Filming from above is okay for how you move in the boat and in it. So we start with the most important measurement, which is the mast brake position. There are different methods of measuring it, but I know the Americans measure it different than we do. The Americans leave the ram off and let the mast bend, which I think is not very accurate, because if it's bending and you measure from there to here, the bend has an impact. The top can go further back. So then it's super critical how much shroud tension you have. More shroud tension is more mast bend. So we measure always, you pull the ram down so that the mast is straight. Because straight is straight. It's a very clear definition. You look up the mast, no bend, straight. Then you hoist the tape measure and 0. You hoist it so on a shackle here. 0 is here, at the black band. So if you have a mast with a halyard block, okay, you know, there it is. If it's a rope halyard, you have to turn the boat over and check if 0 is there. So that boat has a main halyard block, so we just put it up and start with 0 there. You put rig tension on. The shroud tension with a straight mast has nearly no impact on the mast rake. So you put the shrouds tight. It's not so important if it's that tight or that tight. Just put it tight and that's it. And then you adjust the ram so the mast is really straight. And then you measure over the transom to this underside. Because measuring here makes no sense, every boat is different. So you measure to here. And you have the whole range has to cover the range from 788, 790 down, which is 5 knots, down to 750, which is 30 knots. And that's the range the boat has to work in, because you can race in 5 knots, and it can happen that you're racing in 30 knots. You might not start in 30 knots, but during the race it can get so strong and you have to be able to sail the boat. So you have to be able to cover that whole range, which is a lot. So the boom can be like this, or like this. That's why the main must have this flattener here to tie this down to lift the boom, because it gets too low. It touches the seat tank. You cannot go under it because we're all old, and also because the boom vane, you see, it's a 1, 1, normally 1, 1, and a double here. 16. That's the purchase you need. Less is not enough. It goes down too much and it does not work. So when you put the flattener on, the boom comes higher again, and the travel range for the boom bank is okay. Americans, when they sail on really windy stuff in San Francisco, they have 2. Because that's just very special San Francisco. So we check on that boat. I'll show you that travel, that range. Measure the mast rate, and somewhere in the boat you must have an indicator showing the mast rate. Super important. Then jib. Jib sheeting. That's the sheet. It's going here, back, return, something to the front. All boats now have the cleat here. Nobody has it in the back because you want to tack with the face looking forward, and you don't want to have any sheet in the way here. It has always to be, and the old boats had a cleat here. Didn't work because you have to tack back, face backwards. This middle of the boat to the jib leaf, in out. We have to check that. You have to measure. This has to be in out. You have to be able to do a range of 48, 49 to 70 centimeters. Because when it's windy, you go there, and the jib is like that, flatter foot. So the in and out is really important to know. Up and down, it's very difficult to measure. You look through the main and you can see it. But in and out you can measure, because from here, the crew, here on the wire, that's one, you cannot see how far it's in and out, because you look 90 degrees to it. You cannot see the deep. You cannot see that difference. So that's also a very important measurement. Well, yeah. So you must have these 2 indicators. We also have one for the short tension with some numbers which say nothing. It's just 1, 2, 6, 7, 8 memory, only memory. It doesn't say how many kilos or what, blah blah blah. That is just for memory and comparison from one boat to our training partner. To be full, and the mast straight, and straighter, more powerful mainsail. So you have less tension on the shrouds. The more breeze, the more tension on the shrouds.
So like there, it's ram up to the power.
That's very light, yes.
And that is also decreasing or increasing the force stays south.
Exactly. So when you have more mast rate, so the mast, it's difficult now, the mast comes back, here the spreaders, you have the shroud position here. If the spreader tip is coming more, say here, more behind this point, the spreader, mast, the spreaders and the shroud here will push the mast forward. So you get more bend here. That's why, and it can be too bendy in the middle. And when the main when it's too bendy here, the main does this. Gets too flat. It has a bad shape. Then, if you move this point to here, you see, you get a line like this. and the spreaders are pushing less. So some boats have this adjustable, which is nice. When you go for a lot of rake, you can move it back. Where this is not adjustable, it's okay, you can survive it if your spreaders are not too far back. So this measurement is really critical. If you have fixed chain plates here, you either bring the mast forward one hole. When you know, okay, today it will be windy the whole day, you bring the mast a little bit forward, or the spreader angle is less. That's like you did it for 70, up the mast and adjust the screws. But you can also move the mast forward. So what we have here on the mast heel, you have this hole, and the mast is somewhere here. It's standing on one hole. So this is the mast, and the heel is, but it's not standing. It's standing on one hole. It's not between two holes. So if this is not a fixed ball but a long pin, you can pull it out, slide the mast, and plug it back in. It's difficult on the water, but you can do it in the morning when you know it's windy all day, and I can't adjust this. I'm bring the mast one hole forward, because then it's not so critical with the spreaders, because you gain mast position, you gain in between this. It's the same like making that less. That's why I wanted to measure yesterday, where's this position, where's that position, what is your spreader setting? And you remind me, we have to check when your mast is out, because this is the mast section, and on the heel plug in the bottom it looks like this, right? If you look above and you have the spreaders and the shrouds here, yeah, you look from the bottom of the mast up. What we do, exactly, this is 90, and this has to be 90 degrees, the heel to the spreaders. You see, this is off asymmetry. So on one tack and the other, your spreader angle is different. So this has to be 90 degrees. You know what God made first when He made the whole world? The center line. So everything has to be symmetric, 90 degrees in center and an end. So this is, when the masts are out later, this is a check on every boat. If this, I've seen a, what's it called? Yeah, I've seen one around. So we check this, put it against the mast heel and check the spreaders. So when I do a new mast, because this bracket is on the mast, okay, I take that as given. And they have a template to do it all, and it's quite okay. I put on the spreaders. You see, there's the fitting, outer hole, inner holes. So I put the spreaders on symmetric, same holes. Then I put the heel plug in the mast and I check it. Then rivet, rivet, rivet. So this is 90 degrees, the mast is fine. I put it in the boat, and this part of the boat is here, you see. I put this in the bottom, and I put one screw to fix it fore and aft, and I put the mast on, but I can turn it this way or that way.
The mast step?
Yeah, so I have one screw, I put tension on, but I can still turn. And then you have the shroud here and the shroud there, and I go 10 meters away. You can check it on the boat. And I look from here to the shroud and the other side, and it has to be one line from the bottom to the top, and also at the spreader. So it's 90 degree square. And only if that is sorted out in line as well, then I mark the side of the fitting on both sides, mast comes out, and then I screw it down. So everything is square to everything. No bend. So I start with the mast, and then the last thing is in the boat. Because if you just screw this down in the boat, it will never match the mast. It's how you look down and how do you guess this? So, and what I've done to check symmetry, we've done in the front where the dip attachment is, and on the transom, in the middle you have the rudder fitting. We've done a string line.
You could put a laser?
Yes, exactly. That hole on new bolts is good. That hole is because the new deck mode is CNC cut, and it's matching the hull. It comes down always in the same position, because if you look around how the deck is bonded down on the new bolt, the whole glue around is parallel. Because both is cat design and it's really matching. It's like you have this glass and you put a cover on top, and it goes down and it's matching everywhere. So the new boat, you can really see it is symmetric. Also, when I do the fit out, and we have templates for the foredeck, for the seat tanks, everything. When I cut the bar for the traveler and go from middle of the boat to both side tanks, it's by a millimeter really, really symmetric from center of boat to each side. Which is a big advantage when you do the fit out. It makes it so much easier than an asymmetric boat. Like on the older rod bars, this is a hull and the centerboard case. It was not vertical. It was over a bit to one side. That's why some boats have the plates inside, because it was over to the right. No, I'm not sure. I have to check. We put the plate in on one side, not on the other, just to. So the centerboard comes out, and from the tip we measure. So it goes up. We measure to here, here and there. And with laser, so it was totally asymmetric. That mold was made by hand. So that is a real advantage now with the new hulls. The hull is totally symmetric. So we'll start with this measurement on one example, because we cannot do all bolts. Then you can measure your own bolts, otherwise it takes too long. And then we go from bolt to bolt, systems, question here, question there. I'll show you which lengths, which dimensions like boom wang and so on are important. And yes.
It's never so that you have space there, so you can have to go forward and backward.
You would not adjust much. You will from the back of the mast to the back of the boat. So the minimum by class rule is 30-50. You will not be further forward than 30-90. Depends on this position. So one hole is, I think, is 12 millimeter on the normal. But if you have your proper position in relation to this, you will maybe change one hole.
But you won't have it fixed?
No, you won't have it fixed. Yeah. Important here, another point is
Jag var säker på att du hade varit och bytt pengar, Thomas.
This is the mast. The big detail. The bottom. And this is the mast here. It should never be like that. It must be like this. As the mast goes this way. If it's just standing on this corner, it puts just pressure on here and not there. So it'll create some bend in the mast. This needs to roll on a radius. So the underside, the highest point is here. So when it's standing vertical, it's maximum height. But when you rake it, the backside has to be rounded off.
But is that done from the factory?
No, it's not enough. You have to do it better.
How much should it be?
But have a look when your masts are out.
Yeah.
It has to be better more than not enough. Because if this would be square here, if you rake it, the whole mast would just stand on this corner. So you get some force on the mast here, which means you will try to bend the mast that way. So you rake it back, but this corner will force the mast backwards. So what you get is actually a double S. So many masts will be too square in the bottom. So we have a look at that. So remind me when the masts are out. So we start with that boat now, and then we go ahead with questions and questions.
You have 48, 49 measured. Where in the length were you measured that?
From the middle of the boat, out to the turning block of the jib sheet. In and out. Yes. So, what you need to know as well is some basic important power ratio. Vang 16 to 1. Most simple is block, block, double. That's cheap and has enough purchase. And up here we have the boom here. Best is if you have a, what's it called, snap hook?
Piston.
Yes. Like your boat. Perfect. You hook it to the boom vang is here. You can hook it there because then it's easy to take it off and on when you're launching. In very light wind you take it off, and here you don't need a block. The friction eye here is good because here you move only that much. High load, little movement. The ball bearing makes no sense. So you gain maybe 2 centimeters here, which here is 4 centimeters. And you need, the cap is here, the bulkhead is here, so you only have so and so much treble. And the boom vang, when it goes from here back to skipper and back to the other side, this must be one continuous rope connected with a takeout. Because you always bear away to the left. So always on the right side, out of the cleat. And if it's not one endless rope, second time going round, oh, no more rope. I cannot ease the vang. It must be continuous. And I can show you, I will show you how to connect core and outer skin. It's very simple. It has to be a connection which is inside in a different location than the outer side. So you connect the inside and then you move the outer skin over it and then you sew it. Because it must be solid. Even if this connection is in the part under power, it should be safe. Because you cannot wash always where it is. Same for the mast rake. You want to have it really continuous one-piece rope ideally. So I'll show you on that boat. And we also do it as a continuous rope for shrouds. And the take-up, the elastic I have here, for the take-up on shrouds and forestay is the same elastic system, because if one is loose, the other one gets, if you have more rakes, so the forestay comes loose, the shrouds are put on. So the take-ups, one comes loose, the other tighter, so it compensates a little bit. Talking about take-ups, every elastic take-up, every elastic rope on the boat, 2 years, it just gets old because you stretch it. The outer skin is protecting the rubber inside. When you stretch it, the outer skin opens up some gap. UV gets inside, it's breaking down the rubber. Yes, it's getting old. It's losing the elastic. Forget about it. It's not so expensive. So you just buy 30 meter or 4 millimeter elastic and you replace it. Because if the rope is not tightened up and you want to grab it and adjust something and it's just lying down and you cannot reach it, it's shit. The tension has to be so that is always, the slack is out, the skipper can always reach it. And we've tried many types of elastic. And it's very simple to say which is the best. The elastic from Leros works best. It has the best, you stretch 1 meter or 5 meter, the best ratio of length to how much I can stretch it. Which means the best ratio of stretching, coming back, stretching, coming back. We've tried several elastics, and that worked best. So I use, I don't know, something like maybe 2,000 meter or 4 millimeter per year or whatever. I don't know. We use also on the 3 millimeter Dynema, we use many meters per year. And we also tried many types of ropes. Some are shit because, for example, with Leros, who does the best elastic, the ropes are shit. Because you have a 4 millimeter rope and the Dynema core is only 2, while others are probably something like 4 or a little bit more than 4 outside, but the core, which is the expensive part, the skin is just polyester, is 3 or more. So you get a much better rope because the core is better. So there's many choices, but you have to be really selective what does the job. I'll show you, especially for example on spinnaker pull ropes, which you have to taper to make it run smoothly through the pulls and so on. I'll show you how it should look like, how the taper should be, what the dimension is. I have some samples here, and we have to look at it because the pull system has to run so smooth, not to mess up the jibe. It must fly back, it has to run all the time smooth. You have to check it every day. After 10, 20 jibes, it has to come out. You have to take you have the elastic for the take-up, so it's not hanging down. It has to come off the rope. You have to do it again because it gets some twist. Because the spiral is 45-degree angle, so it creates some rotation on the rope. And you have every day after sailing, pull it out of the pool, take the take-up off, stretch it, take the twist out, redo it. When you do many jibes, and we have 4 races per day, I can do it on the water because it comes out of the pool end without taking the fitting off. You pull it out, take the elastic off, put it back on. So we even do it in between races to avoid the twist. When it's all new, it's good. The older the rope gets, the more twist it gets. So we check on that boat now, okay?